Alrighty, so we are going to go through a couple of examples now really quickly on the from the vocab on the sheet before on page 2. Your answer you should have gotten after you put that in your calculator, you should have gotten 4 over 663. My video cut off when that happened, but 4 over 663. And you're going to get big numbers when you do those problems, and that's okay. The card problems are okay to get big numbers. But now we're going to be on page 13 and do a couple of examples. And these first examples just work with independent versus dependent events. And so remember, independent events do not affect each other. What happens in my first event doesn't really have an effect on my second event. For dependent events, that's not the case. So let's just see. Tony picks a random card from a standard deck of cards, looks at it, puts it back, which is important, puts it back, and then chooses another random card. These two things, because of the fact that Tony put the card back, these two things are independent. And I'm just going to write an I for time's sake. That's I for independent. Because Tony chose a card and he put it back. Then he chose another card. Because he put that card back in the pile, it's okay. He still has the same complete odds of picking his second card than he did his first card, because everything's back to normal when he puts that card back. Now Tony picks a random card from a deck of cards, looks at it and puts it aside, and then chooses another random card. Now Tony's picking a card, he puts it aside, puts it in his back pocket, and then chooses another card. The fact that he put that card aside completely will affect what happens when he picks that second card. It'll affect his probabilities. The probability of his second event completely depends on the fact that he put that card aside. His chances are different now. So this is a dependent event. So I'm just going to put a D for dependent. Miss Hughes asks a student's age and then asks what year he or she expects to graduate. So the two events, your age and the year that you expect to graduate, those two things do matter with each other. Your age and the year you expect to graduate are related. The year you expect to graduate does depend on your age. There will be a few outliers where you can graduate high school very, very early and very, very late. But the norm is you can't graduate until you reach your senior year, which usually happens when you turn 17 or 18. So those things do depend on each other. They do. And lastly, Jocelyn and Alex want to go get their nails done by the same nail person. Jocelyn calls and schedules an appointment. Then Alex calls and schedules an appointment. So the fact that they want to get their nails done by the same nail tech is very important. Jocelyn calls first and then Alex calls. The probability that Alex gets in on an appointment that day completely depends on what time Jocelyn picked. So Jocelyn and Alex, their ability to go get their nails done by the same person and make an appointment completely is affected by one another. Because they want to get the same person to do their nails, Alex's chances of getting an appointment depend on what Jocelyn said. If Jocelyn chose a 2:00 appointment, Alex cannot go get a 2:00 appointment. So that is also dependent. Alrighty. These just take practice, and as you might need to have a conversation with yourself, you might need to talk out loud about it, but you can let me know if you do not get one of these and I can further explain it. But question 7 says, suppose that A and B are independent events. What is the probability of A and B if the probability of A is 1/2 and the probability of B is 1/4? Change those numbers, please. Well, this is just asking me to mess with the formula. I know that the probability of A and B, no matter what, in order to find this, I need to multiply their probabilities together. And since these are independent events, their probabilities are completely independent, so I can just multiply their probabilities together and not really think much about it. I do know the probability of A, which is 1/2, and I know the probability of B, which is 1/4, and if I multiply those together either in my head or in my calculator, I get 1/8. I'm going to do one more video, maybe 2, on 8 and 9.